Okay, so number 14 says solve the inequalities. Okay, so we're going to treat this inequality as if it was equal to 0, just so that we know all we're doing is just factoring, just like we've been doing, okay? In this unit, we've done a lot of factoring, and that's all we're going to do to both of these left side of the equal signs, okay? So let's go ahead and begin. So if I factor this, I am going to try to GCF, which in this one, it doesn't really GCF out any common factor, but over here it does. An x is able to be pulled out, and an x squared minus 1 is remaining on the inside. Now I'm going to go ahead and just continue to write this greater than or equal to 0. And now because this one did not GCF out, I know I'm going to have a possible two binomial pieces that are going to factor. Okay, so let's go ahead and look at this very methodically. These two will multiply again to get x squared, so most likely they are x and x. The next number that I'm concentrating on is this positive 3, which with these two terms would multiply to. So the only thing is 1 and 3. And now we just have to concentrate on the signs. Okay, so what should the signs be? Well, not only do they have to multiply to get a positive 3, but they also have to add to get this middle piece of a negative 4. So they're going to be negative on both. Again, negative 1, negative 3 gives us that negative 4. Negative 1 and a negative 3 multiplied gives us that positive 3. So here we go. Now that I have my two binomial roots, if you will, or factors, I need to write down the solutions to these. Okay, so here we go. This first one is x equals 1, and this is x is equal to 3. So just like a number line, I'm going to go ahead and write 1 and 3. And this equal to piece right here, okay, that equal to piece right there on the inequality shows that it will be closed. Okay, so it's going to include, per se, it's going to include this 1, and then it's going to include this 3. Now we want to know everything that is less than 0. Guys, if you see something less than 0, just interpret it as negative. If you see something greater than 0, interpret it as being positive. So negative versus positive, okay? So I'm going to test now 3 separate intervals, and all I care from using this equation here is when is the product positive and when is it negative. So let's test the number in this first interval right here. So something less than 1. Probably in this case, the easiest one is to test 0. So we're going to test like x equals 0. And that means that you're going to plug it in right here where you see x and here where you see x. So if I plug in a 0, I get a negative 1 and a negative 3. And since I'm multiplying these, I really don't care about the 1 and I don't care about the 3. I just care about what is a negative times a negative, which in this case is going to give me a positive. Alright, so the next interval that I'm going to test is going to fall between 1 and 3. We can test 2. Okay, so let's try x is equal to 2. Again, we're going to plug that in over here for x. So 2 minus 1 is 1. And 2 minus 3 is a negative 1. All I care is it positive or negative when I multiply? In this case, it's going to be a negative. And then last but not least, we're going to test out our last interval. Okay, so something that's bigger than 3. So we could like say 4, if you will. Again, we are going to plug it here and here. 4 minus 1 gives us a positive 3. 4 minus 3 gives us a positive 1. And a positive times a positive, last time I checked, is still a positive. So now we have 3 different intervals with signs of positive, negative, and positive. And what we care about is when it's negative and equal to 0. So it will be, the answer will lie here because that's when it was negative. So we're going to show that as x's that are in between 1 and 3, but they are greater than or equal to 1 and less than or equal to 3. Remember, we have to show this equals piece because of the fact that we had an equals piece way up here in the original problem. Okay, like that. So this is my answer. So you can write it like that, as far as in inequality forms, okay? Alright, so now let's come over here to part B. Part B, I'm going to factor out this difference of squares. Okay, it's not a sum of squares, so there aren't going to be any I pieces. But we know this difference of squares will factor to x and x. And the square root of 1 is 1 and 1. And we have 1 as a positive and 1 as a negative. Okay? So now we want to see, now we have 3 factors. So we're basically on this number line going to have 0. We're going to have negative 1. And we're going to have a positive 1. So when you have 3 zeros, you're going to test 4 intervals this time. See, on part A, we had only 2 zeros. That's why we tested 3 intervals. Alright, so now we need some test points. We could try something that's less than negative 1. We could try negative 2. We could try something in between negative 1 and 0, like negative 1/2. And then this over here was 1. So we're going to try something between 0 and 1, which could be a positive half. And then this last thing, something that's bigger than 1, we could try like 2. Okay, these are our test points. And again, we are plugging these test points. Each time we're going to plug 2 here, 2 here, sorry, a negative 2, and a negative 2 there. So we'll get, here we go, let me make some room. So I'm testing my test points. So if I plugged in negative 2, I get negative 2 here. And then negative 2 plus 1 is a negative 1. And a negative 2 minus 1 is a negative 3. So I have a negative times a negative is a positive 2. But then a positive 2 times a negative 3 would give me a negative 6. Again, all I care is that it was negative. So let's write a negative down here. Okay, so now if we try negative 1/2. Okay, I'm going to get a negative 1/2. I'm going to negative 1/2 plus 1 is a positive 1/2. Negative half minus 1 is a negative 3/2, or negative 1 and a half. So I have now a negative, so let me highlight this in green so you can see it better. A negative times a positive times a negative. Again, I don't care what the numbers are. We're going to multiply them all together anyway. I just care is a negative times a positive times a negative will result in a positive. Okay, because these two negatives make a positive, and if I multiply it with a remaining positive, I still have said positive. So we can even write it. I'm going to write it down here because I'm running out of room. Now if I put a positive 1/2, this is my next test point. Let me write it over here. I'll have 1/2, and 1/2 plus 1 is a positive 3/2, and 1/2 minus 1 is a negative 1/2. So a positive times a negative will give me a negative for that third interval. And last but not least, the 2. I have 2. I have 2 plus 1 is 3. And then this 2 minus 1 is 1. So that's all straight up positive. Okay, so recap. I'm looking to see everything that is bigger than or equal to 0. Basically saying everything that is equal to 0 or positive. So here are my answers where it's positive. And then we just got to make sure that we account for that equal to piece. So let's go ahead and write negative 1 all the way to 0. X's that are greater than or equal to that, less than or equal to that. And then this other will be x's that are greater than 1. So x's that are greater than 1, you're not going to write it like this with infinity like this, okay? For 2 reasons. 1, we cannot reach infinity. So this would be open. But at the same time, you don't write it in this, almost it looks like 3-term notation. You're just going to write this as x's that are greater than or equal to 1. Okay, which of course you can write it like this too if you prefer. So x's that are greater than or equal to 1, and then this other piece right here where x's are between negative 1 and 0, including negative 1 and 0.